How's it going, everyone? Vlad here, and welcome back to the channel. Today we have a very important topic as it concerns industrial and manufacturing safety. So we will be talking about the hardware that you need to be using in a lot of the applications, whether you're on the engineering side, on the operation side, if you're managing some of these projects, if you're allocating capital and dealing with groups that will be modifying or maybe installing some of the equipment that requires you to have some of these safety components. And so my goal today is to start with the very basics so that you understand what machine safety is all about. And then we'll progress through different levels of safety, discussing some of the challenges of adding, for example, drives that have safety on them versus adding drives through contactors that are safety rated. We'll also talk about more advanced applications, how to install light curtains, how to wire in properly some of these safety circuits. But before we do any of that, I do want to give a disclaimer. None of this is to be used or taken literally. So you need to do your own due diligence. You need to do your own risk assessments. None of this will apply exactly to 100% in your specific case and scenario. And you need to be doing work with responsible engineering teams that will provide the due diligence necessary for your specific application before deploying and deeming that safe for the operations team on the plant floor. That being said, without any further delay, let's get into this. So some of the modern safety circuits have gotten quite complex. And so here I have an example of a guard master relay from Rockwell Automation. And this is going to be slightly more advanced than I wanted to discuss in this video. That being said, if we take a step back to the basics of safety, this will still apply in this case. And if you're working with something a little bit more advanced, you definitely need to make sure that you read all the data sheets. So at the core, safety is going to be a circuit that's going to confirm the functionality of multiple items. And so for now, I'm just going to draw them as a box to simply represent that the state of those safety devices needs to be okay in order to allow machine operation. So think of it as a chain of different elements that, if satisfied, allows your machine to move and to operate. Now, how does that actually work? Well, number one, when you're working with machines, they need to be shutting down based on your risk assessment in terms of different energy sources. So typically that's going to be mechanical, that's going to be chemical or process, that's going to be electrical, and that's going to be pneumatic. So of course, how you define that is going to be based on the risk assessment, but basically speaking, you have process and you have electrical. And so what you want to be doing is ensuring that the machine is safe to operate in the state that it is in. If any of those conditions are unsatisfied, you definitely need to be dropping out the sources of energy for that specific use case. So how do we do that with an electrical circuit? So let me just erase that really quick. What I will be explaining is the most fundamental basics of safety circuits, right? So normally, you will have what's called a safety relay. The safety relay is going to have a contact which, and bear with me, we'll get into dual channel safety if you're looking at this, is going to check different devices. So here, again, this can be represented differently depending on your drawings, but this is going to be an e-stop, this is going to be another e-stop, this is going to be a light curtain, and how it's represented is going really to depend on the schematics, but that doesn't necessarily matter in the context of this specific visual. And so this wire is going to come back to your relay and come in right here. Think of this as one single channel. So the relay is going to emit 24 volts. So here, if I bring in my voltmeter, and of course it's going to be connected to ground or 0 VDC, but basically if I measure the voltage here, currently it's 24 volts. Right now, as you can see, my e-stop is hovering above both of those points, so it is not allowing the signal to go through. So here we have 0 volts. Consequently, we have 0 volts here on the first channel, which basically means that the current application is not safe, or the current machine is not safe to operate. And so that's going to be, again, relayed by the safety relay to other devices within that specific electrical panel or electrical chain, that this is not safe. So here I'm going to say not safe. Once I close all of these elements, right? So imagine that now there's a contact being made with the push button. There's a safe condition with the live curtain, whatever that means. Again, there's going to be usually a controller for the light curtain to say it is safe or it is not safe. There's a lot of different complications. It can be muted. So there's a lot of different tools to work with something as advanced as a light curtain. But in this case, we now have a chain going through 24 volts, all the way back to the safety relay. So here we're now reading 24 volts. And basically, it's going to say that the application is indeed safe, and we can energize whatever equipment needs to be operated based on the state of this specific safety relay. Now, let's introduce another component. So in most applications, the safety relay is not going to automatically confirm that it is safe to operate. A lot of times you have what's called a reset circuit. So here, in its most basic form, again, you can either have a switch, it could be a push button, but all you have here is 24 volts DC. And basically, once you complete the circuit by pushing a reset button, you're going to allow the safety relay to check that the status is indeed safe, and we can now operate the equipment associated with that specific safety relay. Now, let's move on to a slightly more complex concept. So if you're working on very old equipment, chances are you have single channel safety. These requirements have been updated over the years. I don't know all of them by heart, but basically if you're touching any machinery in 2025 and beyond, chances are you need to have dual channel safety. And I would say it is rare, although not impossible, to see a lot of single channel safety rated circuits in manufacturing today. So you should be aiming to design and work on circuits that are dual channel. So what does that actually mean? The concept is fairly simple, and I want to say analogous to what we discussed with the single channel, but basically instead of having a single wire coming out, every relay is going to have two wires. Now, does that mean that every single device on that chain needs to also have two contacts? And the answer is yes. So in order for it to be safe or considered to be safe, you also now have what's called dual channel safety. And so every push button and every e-stop or light curtain or any safety device is basically going to have two sets of contacts instead of one. And the reason why, and obviously once it's explained, it's a little bit obvious, but you don't want to have a single point of failure within your circuit. So for example, if you have a regular push button or a regular selector switch, those contacts may fail and they will basically close the circuit without your ability to push that push, and they will cause the safety circuit to confirm that everything's okay when in reality it is not. Therefore, it is extremely important to use dual channel safety devices with a dual channel safety relay when working in safety circuits. As you can see, now I need to maintain basically 2 points of failure in all of my circuitry. And here I'm going to just bring this back. This is a fairly common application and a fairly simple one, but what you're looking for here is, first of all, you're going to have 24 volts on each channel. So first and foremost, if you're troubleshooting this kind of circuit, you need to validate that you have 24 volts on each channel. A lot of times it is done internally specifically to make sure that the relay is actually working. But basically, you're going to have to check that there's 24 volts along the entire chain for the safety relay to say that both channels are okay. And a lot of times you will have a set of LEDs. I don't know how easy it's going to be seen on the actual safety relay, but basically there's going to be 2 LEDs that indicate the status of each channel. And so once the channels are okay, right? So if everything is correct and everything meets the safety requirement, again, the push buttons are not pressed, the light curtains is not obstructed, then you once again have 2 channels confirming that the safety is okay on both channels. And so here, it's very important to understand that as soon as you introduce dual channel safety, you need to basically have both channels correct in order for the relay to allow the downstream equipment to run. Let's switch gears and talk about what I call downstream equipment when it comes to safety. So in a lot of different applications, you're going to be using motors, you're going to use valves, you're going to use conveyors and pumps tied to those motors. So what does it actually mean for them to be rated for safety? Well, a lot of times there's going to be different approaches on how you wire some of your equipment, and based on how you wire, it's going to indicate whether it is safe or not. So what I mean by that is your PowerFlex, for example, there's going to be a way to wire it for safety rated circuitry. And so I don't know how well you can see it. I'll also post a diagram, but basically here on the bottom left hand side, you will notice that there's going to be a terminal that is painted red that allows to wire in both of these channels. And only if both of those channels are okay, again, you can program some internal confirmations. This is going to be coming in with a jumper, but only if those channels, and if it's enabled, if the channels are okay, is this PowerFlex going to be allowed to run? So it is very important that you wire this incorrectly if this is a requirement for your specific application, because basically it is not enough to, for example, take one of these channels and to wire this into a PowerFlex on the run side. So if you do something like this, where you plug in the PowerFlex, in this case it's a 525, but it's standard across most VFDs nowadays. So if you just wire in your safety relay into the run command and you leave the jumper in, the PowerFlex will run, but this will not be a safety rated application. Obviously, once this breaks, right, so if the safety relay becomes unsafe, it's going to break the signal and the PowerFlex will stop. But it is important to use the safety rated inputs for all of your devices. And the same can apply to a variety of different things. So if we look at, for example, a contactor, you will notice that normally you have a much smaller device and footprint, but in this case, you have an add-on that is rated for safety. The same goes for your push button, and the same concept goes for everything. The technician or engineer or a systems architect, it is definitely possible for you to create a normal ice cube relay system that would meet similar requirements. But remember that it needs to be rated for safety for you to consider that application safe. So it is important not to create scenarios where, for example, and I've seen this done in plants where they would bypass one of the channels, and this would be basically a normal push button that is not e-stop dual channel rated. And so, of course, a very simple relay is going to allow both of those 24 volts channels to go through. It will satisfy the conditions, but if something were to happen and this button were to fail, you're going to be in a lot of trouble, not only in terms of damaging equipment, but also potentially putting or having put personnel at risk. So like we discussed, you can have a relay which is going to output two signals that are going to be checked by the inputs for dual channel safety. What is possible for you to do is to create a chain of relays. So here I'm going to have a second, which is going to basically consume these signals, and it's going to emit its own circuit. So here I'm going to have a set of e-stops, right? So this is going to be a set of, again, push buttons, and my drawing is not going to be very pretty, but hopefully you understand the concept where you have a push button here, and then this is going to go back into this specific relay. And so here I'm going to have, for example, a push button to reset the circuit. And the reason why you need to do this, right, and so this is going to be the chain which will basically check an array of safety relays, is that you can create circuits that are going to be checking for different areas where this is basically daisy chained until it comes back to what's called a master safety relay, which then allows very specific sets of equipment to run. And just like you have in this case, you can also allow very specific sets of equipment to run. So to give you an example, this can be done in a palletizing area where you have the master circuit responsible for the palletizer, the secondary circuit responsible for some of the conveyors, and the tertiary circuit responsible, for example, the stretch wrapper. And so just to illustrate the scenario, so if you're looking at an application as complicated as this, first of all, you need to be very clear on what your wiring does, where the e-stops physically are present, and then which devices are allowed to operate based on which relay. And so again, just to illustrate how complicated this can get, in this scenario, you have a palletizer that requires all of the safety to be correct in order to work. And basically this is going to have its own push button for reset. Again, this is not overly complicated yet. We'll talk about even more complicated scenarios, but you have a conveyor system that is allowed to run, again, based on its own e-stops, while the palletizer may not be satisfied on the safety side. Similarly, if you have a stretch wrapper that you've added, right? So this is an entire cell or entire maybe area that's operating, but the stretch wrapper can operate based on its own e-stops and its own areas and its own maybe light curtains while the palletizer is down, but the palletizer needs to meet all of the safety criteria for all of those areas in order to start operating. So one of the most common questions when it comes to safety circuits is, how do we troubleshoot them? Can we get better at identifying where the issues are? And so the first check that you always want to do is double check your e-stops as well as your light curtains, right? So typically when you have a stop that's going to be on a conveyor, it's going to look something like this, and it's going to be either pressed in or it's going to be pulled out. And so you often need to basically twist the e-stop, pull it out, and it's going to be basically turned off. And so here it's going to be illuminated. So the first step, obviously, it's to check the physical devices, right? And this is going to be some kind of a box where the wires come in, but you want to double check that none of those are pressed. The second step that you should be looking at is your electrical schematics. So your electrical schematics are going to contain the information that I basically drew very rapidly on the whiteboard, but you should have a set of safety relays that will be connected to usually e-stops and obviously other devices, but it will tell you, so this is going to be e-stop, e-stop at discharge. So you should probably be looking at that specific e-stop if you're looking to understand whether or not it is correct. Like I've mentioned a little bit earlier, what you need to be doing is measuring voltages. So your schematic and your device will tell you exactly or confirm that's the case, but a lot of times all you're doing is tracing the 24 volts around a loop. And like I've mentioned, if you're measuring 24 volts here and then you're measuring 0 volts here, you can immediately tell that your e-stop specifically here is not being made. And again, obviously that in a normal e-stop that is functioning, that's going to be indicated by the light, and that is usually wired on a different circuit. But anyways, the point is that you should be measuring your loop around the various devices on your chain. And then once you complete the circuit, right? So you've confirmed that here you have 24 volts and here you have 24 volts. In most cases, the relay will require a reset signal. So again, so of course, if you have 24 volts here, and then when you press the button, you also need to have 24 volts. And this is going to energize both of the channel outputs. So again, this is going to be different LEDs depending on how this looks, but your safety circuit is going to show with LED status indicators that everything is looking good. And like I said, this is going to be varying based on the specifics, but ultimately that is the base case scenario. So in some very extreme cases, you need to bypass safety circuits. And this is not something I would recommend lightly. This is not something you should engage in if you don't have full responsibility, full control, full understanding of what you're doing. But in certain instances, during, for example, commissioning or startup, you need to be able to bypass a certain feature in order to understand where the failure points run. And of course, as I've mentioned a couple of times, you need to make sure that no personnel is present. Only the ones that understand the risks of doing so are present. But in this scenario, you have two channels of 24 volts. And so you can shortcut basically on the same inputs, you can shortcut the 24 volt signal bypassing whatever is here. And so as an electronics tech or engineer or even director level, you should understand that all it's really doing in this case is looking to make sure that you have 2 points of contact going through the circuit. And so really all you've done by placing these jumpers in place, you have disabled the entire chain of safety that enable that specific relay. And like I keep mentioning, this is not something I would recommend doing, but I do see instances where this is basically required in order to troubleshoot some other issues or maybe to allow a specific part of the process to run as we understand what is going on with specific precautions in place. So this is the part where we get to some FAQs, right? So if you have a dual channel safety relay, these are some of the things you should not be doing, right? So if you have two channels that need to be 24 volts confirmed, and then sending a single wire down a series of push buttons that are not dual channel rated, and so here at the end, you're again splitting off that signal. You should obviously not be doing weird things with your push buttons, right? So again, you can send a single wire even from a single channel, and despite having a push button that is rated for safety, you could do a interesting wiring schematic, something like this, where you come in and you come out with a single wire. And this is a little bit maybe difficult to understand, but you're basically looping both channels as a single wire through that same push button, rendering it essentially on. The other thing on the output side is, as I mentioned, you always have two signals confirming that something is safe. And as I've mentioned to you on the PowerFlex side, you have two inputs that need to be energized by a safety device in order to confirm its safety. So if you have two terminals expecting dual channel safety, this is the way you should be wiring this. You should never be shorting the two signals to a single channel, because ultimately you are rendering your application unsafe. So there's going to be a lot more, obviously, nuances, and there's a lot of questions as to how you can, for example, work with light curtains that are going to be passing, let's say, pallets through, but the person that's working on the pallets is not allowed to put their hand through those light curtains. There's going to be a lot of different applications that you need to be referring to your data sheets to understand, but I hope that you understand the most basic concept of safety circuits that I don't think everybody appreciates and understands well enough in manufacturing and industrial automation. So just for review, when you have a safety relay, it is usually outputting two signals of 24 volts DC, and both of those signals need to go through a series of safe rated devices, which include e-stops. They include your light curtains and a few other different schemes, but ultimately they need to be received by the same safety relay in order to confirm that those devices are in the right state, and then it's going to output a signal on two channels that the application is safe after receiving a confirmation of a reset. And so again, I've mentioned a couple of times that this can be used via a push button. Certain relays allow you to automatically reset that circuit, but again, that depends on your specific application. So I want to revisit this reset function just a little bit. This can be a push button, and a lot of times you will see this in automation. If somebody pushes this push button, it's going to close the circuit, and if everything is good, allow it to reset. Of course, you can put different things in series with this specific reset. So you can add the checks, for example, on your PowerFlex drives. You can add other checks in your software. So understand that this circuit is not necessarily safety rated. So your reset can be based on a variety of signals, and you can add different things as part of the circuit. Again, this could be switches, this could be contacts, right? So I'm going to just add a contact here that needs to be made in order to allow the reset. So the other question that gets brought up is around other safety components. So if you worked in industrial automation long enough, you will know that there's going to be what's called safety PLCs. Safety rated PLCs are usually going to be, number one, more expensive. They're going to be dual redundant, so they are also required to have, again, this is, let's say, an I/O card of a normal PLC where you have a single channel. Safety rated PLCs are going to feature cards with dual channel safety, and then dual channel both inputs and outputs rated for the safety application. So it's also important to understand that when you start working with other components that are safety rated, you need to fully understand which components you can use for a safety rated application. So just because you have a safety PLC doesn't mean that you can attach a non-safety rated input or output card and operate it as a safety rated environment. So it is very important to pay attention to what you're using. You also have what's called safety rated relays, and those are going to be slightly less complicated than a safety PLC, but none the matter, it means that you have a lot of different channels and a lot of different features packed in something that is programmable. Therefore, it also means that you can make a mistake beyond just the wiring. It also lies in your ability to program or set up this device for a safety rated application. So I would be paying very close attention if this is something that you're planning to use, or this is something an integrator or maybe a machine builder is using for you, because it needs to have the right components in place. There's also now a lot of conversations and a lot of applications of safety over Ethernet IP, or basically TCP IP based protocols. And so it is definitely possible. It is something that Rockwell has released a number of years ago, but now you can also have safety not only via hardwired I/O, but what's called distributed applications. So again, if you have a safety PLC, you can, for example, talk to a switch, and again, there's going to be different configurations that need to be in place. I'm just going to very quickly illustrate this. And this PLC is going to talk to some kind of a safety rated, so safety remote I/O. And this is going to obviously prioritize the traffic. It's going to shut down if it doesn't receive a packet after a certain amount of time. But this is also going to allow you to create a more distributed environment where you have a safety PLC maybe inside of the cabinet, and then you're looking to have some I/O that is going to be safe, specific for a different area. So there's going to be a lot of different options where you can create a system that is going to be quite a bit more complicated than what we've discussed a little bit earlier. The last item I will mention is that different lines of safety relays are going to have different features in place, and they have gotten quite complex themselves. So you will notice that not only is this relay dual channel, it also has different features as indicated by the selector switch on the front. And so it's very important to read the documentation, because this relay, you simply cannot assume as you see it on the panel that it's going to have the exact same functionality from one relay to the other, because it can be programmed via the dial in the front. These relays are also quite a bit more sophisticated. I've actually had to troubleshoot them a number of times, but basically the relays are no longer emitting. So as we've discussed, it's going to be a 24-volt chain. In this case, that is not the case, because these relays are going to be smarter than that, and they're going to be paired with devices where they will check for other signals. So instead of just sending 24 VDC, because people, again, were able to bypass or crisscross cables or do strange things, these relays are going to emit, for example, 24 volts here and 19 volts here, again, depending on the schematic and the specs of that specific device. But if here you have 19, then this 19 needs to come back in the exact same line as it came in. So you cannot crisscross channels and simply bring in 24 volts anywhere and 19 anywhere else. It's also going to handshake with other safety relays. So for example, if you have another safety relay as part of this chain, and this is going to take care of some other circuits, then it is important for that relay to confirm. So here it's going to be, let's say, 24 and 19 as we discussed, and on the other side, let's say it's 13 and 17, and this is going to confirm this specific voltage. So you cannot simply bypass, as I've described a little bit earlier, and expect the system to work. So always read the manual, make sure that you're paying attention. The last mention that the devices usually attached to your safety circuits do not come pre-configured with those safety features out of the box. So just as you need to set up and make sure that the relay circuit is correct, remember that on the PowerFlex, you will have a jumper on the safety side, but you also have certain faults and you have certain features associated with the failure and how safety is handled when you drop the voltages on that side. In some cases, it's going to be an error. In other cases, maybe you need to coast the drive to a stop. So you need to also pay attention as to how you're handling once the circuit is no longer safe on the output side of your safety relay. If you have any questions, if you're evaluating a specific application, or if you're having conversations with your management when it comes to safety or a lot of other different topics in manufacturing, don't hesitate to leave me a comment. Don't hesitate to reach out. If you enjoy this type of content, make sure to tell me as well. If you have questions on other topics, do let me know. And hopefully this was helpful to you and your team.